Cool. Hi, friends, new friends, old friends. I'm Greg, and I'm really excited to be here at Monitorama. I hope everybody else is at least as excited as I am. Otherwise, I'm just going to look like a crazy person. So get ready to have a whole lot of fun these next few days. For those of you who haven't been here yet, it's awesome. So yeah, I'm Greg, and I am the CTO at a monitoring startup called Opsy. And I am basically building the monitoring system I always wanted to build, which is a lot of fun. And a big part of doing that is going around to people and talking to them about their monitoring challenges, operations, infrastructure, all of these things. And a part of my job is reading about operations, infrastructure, and monitoring. And one of my favorite things that I see about once a week is that article on Hacker News that's like, X is dead, servers are dead, monitoring is dead, right? And it's always this, it's always a piece about something new, some slight variation on a theme that's very current. And it's never actually about something being dead, because if monitoring was dead, this would just be Donutorama, and it would be like America's largest donut eating competition, and I would love Jason to rebrand as that at some point, but I'm not super optimistic about that change. But we are going to talk about monitoring, and in order to do that, I want to give some context to the conversation that I want to have with you today. So we're going to look back at the dawn of system administrations, where monitoring really sort of comes from, where we did a lot of things that I think we comically referred to as monitoring. We looked at the big five, and those are all sort of around resource utilization and process aliveness. We'd look at CPU. CPU mattered to us because we had a very finite amount of it and a lot of people had to share it. So we'd have very sophisticated monitoring like this. And what we would do is we'd SSH as root into machines and run mail, and we'd see, the 57 messages that we got from our uptime script. And we'd be like, oh, geez, okay, well, I know the performance profile of this machine because I only manage one server. One! And I log into it every day. And yeah, so we'd know what looked weird just by looking at something like uptime or top. The next thing, of course, we would check every day is memory. How much free memory do I have? Again, highly sophisticated tools were used to discover this. And we could see very clearly, oh, this one process running on this machine is hogging a lot of memory. I'd better kill-9 it really fast. And my favorite thing that we monitored was disk. We would not only look at how much a particular volume was using, but we'd actually have to check every single home directory, because one person could have that 4 gigabyte log file in their home directory because they just left some random thing running for the last 3 months and it slowly filled up home. So we'd have to send them very passive-aggressive emails like, hey, I just catted dev null to this file and I'm not happy with you, see me in the morning because it's 3 a.m. for me. We'd also monitor process aliveness. Super sophisticated stuff here, where we just ps-ef, check that something's in the process table. It is. Great. Okay, good. I'm just going to get a check for that every single day just to make sure it's there so I don't have to run top every time I log in. And then we look at system aliveness. We'd make sure we could get our Usenet binary groups, right? And we'd make sure that we can ping that. And this was really to check for things like routing problems, network issues. I mean, we had reasons for pinging stuff to test for aliveness. And that was monitoring, right? This was the stuff of system administrators. I had a bash script in college that whenever a batch job was running, it would check the process of that job by inspecting log files. And then at the very end of it, it would actually beep me the return code of the last thing that executed. So if I got a page that was 0, I'd be like, okay, another round. And if it was a non-zero exit code, I knew I needed to dash back to the lab. Otherwise, something terrible was going to happen in the morning when the professor checked in on the status of this job. And I said I was out drinking all night. And there's a lot of apologizing that would have to happen. And so yeah, you're really on top of things. And what we had, and what I think we still have, are a lot of thresholds. And as system administrators, we would look at things, and we didn't have static automated threshold checking, but we had things that we thought of as thresholds, like I have so much free memory, so much free disk, so much free CPU. And we kind of standardized around several states for assertions against these thresholds. We had the green state, which meant everything was fine. I have 100 green dots on this Nagios page, and I know that everything's working the way it's supposed to be because something is less than something else. And then we had the orange state. And this is where you had these upper and lower bounds, right? It's orange because it's more than this, which I think sort of means it's okay, and it's less than this other thing, which I know is terrible. But I mean, we still have this orange state that doesn't make a lot of sense, but it's there just so it's like in the corner of our minds. We know something could happen. And then we have the salmon state, and I didn't want to use red because I know a lot of us have serious on-call PTSD issues. And it's for real. Okay, so a quick anecdotal story about red things. We are a startup, and as such, we have built the first web page for our company, right? And Sarah, who is this amazing web designer and just artist in general, I love her to death, she built this site that had a lot of red in it. And the first time I saw it, I looked at it, and it was just like sheer panic. I couldn't control myself. And so I went to her, and I was like, Sarah, I think you don't understand our target audience. I just had to go to the bar, and it's 9 a.m. It can't be red. It can't be red. Please make it green. Use green everywhere. It's a monitoring company. People like green. It's soothing. So she did, and it's beautiful. It was beautiful red too, and there wasn't any true red, but yeah. Anyway, we had this salmon state. What's the problem with this, though? You have to have assertions. You have to be able to assert that something is good, right? Well, there's one thing. What we've created is this ad hoc specification for aliveness. And we've used these big five to do that. And we've done this for 20 or 30 years now. And I think we are outgrowing it. And if you don't recognize this quote, it's from the movie Antitrust, and it's the best scene in the movie. And that's the second best movie, second only to Hackers. And if you all want to get together in San Francisco, I will buy pizza, and we can watch both of them, and it'll be great. Now, I know what you're thinking when I talk about these thresholds and these static thresholds and these assertions. Greg, we have time series data. I can do derivatives. I have percentiles and histograms. Yeah, we've been doing that for a long time, and we have fancier crons now, and we have fancier ways to make these assertions, and we have fancier emails, but it's still more of the same. What we do is we take a single thing in isolation and we make assertions about it. And that's natural because it's an extension of how we test our software. Unit testing is taking a single piece of functionality and saying, oh, it does what I expect it to do, and in these corner cases, it doesn't do this other horrifying mess of stuff. But now, we're building complex distributed systems, and as Adrian just said, they're getting weird, okay? So our style of monitoring has to change with the way we're building things. Everybody's sort of confused. In preparing for this talk, I actually asked people who I think are thought leaders in monitoring. And I went to them and I said, Jason, I know you're a retired thought leader, but what's monitoring? And what it felt like was an editor war. I felt like we had Emacs users who knew things about monitoring and VI users, and then it's like some nano users over here. But nobody cares, right? So it was this weird war about push versus pull, black box versus white box, blah, 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 blah. And what I felt like was I had asked them, what's DevOps? Because when you ask 5 people what DevOps is, you get 86 different unique answers. So everybody's forming these really strong opinions about how we should monitor. And it doesn't feel like anybody's clearly defining what monitoring even is. Calm down. All I asked was, what's monitoring? I didn't need all that. Instead of us positioning ourselves like this, why don't we come together as a community and decide on what monitoring is and what it means? So yeah, let's avoid being the next DevOps. If things go that way, we will be DevOps all over again, and we're doomed. Monitoring will be dead. Let's change the conversation. To solve this problem, let's clearly define things. So I'm drawing a line in the sand today. I am going to define DevOps, me. I'm just going to do it, and you're going to agree with me, and it's going to be great, and whenever somebody asks you what monitoring is, we're going to know. So what's monitoring, Greg? Please tell us, we're waiting. Before I do, we're going to talk about observability. Observability is something that's bandied about a whole lot right now, and I'm okay with that because it's very important, and that's why we're going to start by clearly defining observability. A system is observable if and only if you can determine the behavior of the system based on its outputs. This is an accepted definition of observability from multiple other fields of engineering. If we're going to call ourselves engineers of any kind, I'd like us to adopt this definition of observability. And maybe everybody already has, and I'm just late to the game, and I looked it up last week. But let's just say that this is observability. And if we're going to say that, I want to look at some of the words in the definition of observability. A system, right, is observable. What's a system? A system is a set of connected components. And furthermore, they're components that interact in a way to do something more complex than they would on their own. Monitorama is a system. We're all interacting to do something. Without us, without Jason, without the organizers, without the venue, without the vendors, thank you vendors, we wouldn't have Monitorama. We came together, did something more than what we would do individually. The next thing I want to talk about is behavior. The manner in which a system acts is its behavior. We're going to get together, we're going to have lunch, we're going to talk to each other, we're going to tweet about the conference, #Monitorama. You're going to tweet about me, Greppery, because I'm wonderful. And those are our behaviors. Behaviors have effects, and those effects are outputs. The outputs of a system are the concrete results of its behavior. Those tweets are results. Going to a vendor booth and giving you their email, those are results. More stickers on your laptop are results. Those are outputs. So that's our definition of observability. It's fairly straightforward. We're going to just take that and then we're going to move on. So what's monitoring? I know. I still haven't gotten to it, but we're about to. But first, I want to add a couple of more words to our shared lexicon to talk about monitoring. Components, right? Components are base units of functionality that we combine to get greater types of functionality. What do we need to monitor components? We need sensors. One or more sensors observe the state of components. So things are sensors. Things emitting logs, those are sensors. Things emitting metrics, those are sensors. They don't do anything but observe and tell us about something. Sensor data goes to agents. An agent interprets data emitted by a sensor. And I know agent's a really overloaded term, and I think that we've abused it, and we should stop using it to mean a process that runs on my EC2 instance that does things for monitoring, and instead say an agent interprets sensor data. And I know you're getting tired of me being super pedantic about defining things, but in order to do like the definition of monitoring, which I'm going to show you now, we had to define those things. Monitoring is the action of observing and checking the behavior and outputs of a system and its components over time. I think this is a fair definition of monitoring, and I think we all have been talking past each other about this, and we all inherently know this, but until we pedantically and slowly and painfully define it, we're going to keep talking past each other. So from now on, when somebody asks you, hey, Jesse, what's monitoring? What do you say? You say, monitoring is the action of observing and checking the system and its components, behaviors, and outputs over time. And if you go into an interview and somebody asks you what's monitoring, you will kill it with this answer. kill it, seriously. And then you're gonna be able to go into what all of these individual things are, and you're gonna spend 30 minutes just defining monitoring, and they're gonna be like, let's go get coffee. So that's monitoring. I'm gonna monitor tomorrow night when I go out to dinner at Tasty and Alder, and when the waitress, the agent, says, you have a bill of $150, I am going to say, give me more food, I don't care, I will archive this email. So let's do this. Okay, Greg, this is you talking now. That's all well and good. Thank you for the wonderfully pedantic history and vocabulary lesson. What am I supposed to do about all this? First, understand that things change. We have to accept that the way we build things has fundamentally changed since we started to monitor them, including the things that we built, a few years ago that we built monitoring for. Those have changed radically in the 4 years since we built the monitoring for them. We're making assertions about data all the time. The problem is that we're doing it in isolation. If we're going to monitor complex distributed systems, we're going to have to tackle distributed systems problems. And in order to do that, I think we need to educate ourselves about some of the ways that distributed systems behave and fail. I spent the last month or so trying to educate myself about distributed systems, and I discovered that there's about 30 years of research that I have to catch up on. I mean, think about that for just a second. 30 years of distributed systems research, right? The thing I discovered is that academics do something very interesting. It's probably more than 30 years, but academics do something very interesting. What they do is they come up with a problem statement, and then they flip bits about that problem statement, adding and removing constraints. And one of the problems that they talk about a lot is just how do you detect a fault in a distributed system or in a network? And there are a lot of papers about this, and they go back a long way. Not the first, but one of the most important that I felt I read was a paper that, when talked about, you refer to the result of it, which is the FLP result, named after the 3 authors of the paper. And it's sort of a very general case, it's the general case, I think, about fault detection, where when you say, if we have a totally asynchronous network, that is to say there is no upper bound on the time it takes to communicate, it is literally impossible to detect a fault. Really let that sink in. Literally impossible. Monitoring is meaningless in this case because it can take an infinite amount of time for something to respond. There's nothing you can do to monitor this system. And that's a fairly important paper, and that was 1985, right? Single digits of age for me. That's big. The next thing, and fortunately, our problem is not so general. So, yeah, I went there. So in a more specific case, where it's not a totally asynchronous network, but a synchronous network, where there is an upper bound on the time it takes from something to get somewhere to somewhere else, we have what is referred to as the Byzantine general problem. This is a paper that Leslie Lamport, of course, helped co-author, and it was really kind of an interesting read for me because it introduced me to the idea of Byzantine faults. And it's really hard to summarize what a Byzantine fault is, but I think I've come to an agreement with a couple of other people that it's when something really weird happens, something you do not or cannot expect. So it's very strange, and this is where Byzantine fault tolerance comes from, and that's a whole other set of talks, and we're not going to get into it. The problem we are most concerned with as people that do monitoring is when something takes too long to respond or fails to respond. I have to credit Alvaro Videla with phrasing it this way because it's very funny and I don't know where he got it from, otherwise I'd credit that. But failing to respond is just a special case of responding too slowly. The server took infinitely long to respond. It responded infinitely late, right? That's failing to respond. These are the kind of failures that you have when you have performance problems. This is you have stopped processing transactions for some reason. Something has failed or is responding too slowly. So what it requires to determine that something has responded too slowly is a service level objective. And this is like, these are our thresholds, but we're gonna grow them up a little bit. I really like this term, and I wish I could credit a group or somebody with coming up with service level objectives because it's brilliant. If you know anybody that's involved with doing service level objectives, like really hug them because this is nice. What you do is you say about a service in a distributed system, something like, can it process this specific request? Or can it process any request in a fixed amount of time? Or can it process so many requests per second? These are service level objectives, and they're incredibly helpful to inform things like health checks, better health checks for services. And I'm not necessarily talking about a health check like the Nagios style of health check, like where you pull data or push data. This has nothing to do with push or pull. You have a way of determining the health of your service. And there's gonna be a talk later today by Kelsey Hightower. And I can't give a talk without mentioning Kelsey Hightower, apparently. But it's all about better health checks, and you should go to that talk and you should pay very close attention because it's gonna be good. It's gonna be very good. So what this requires, informing ourselves about how service behaves, means we're gonna have to DevOps this shit up. To me, DevOps is about, it's about collaboration with other engineers. And it's when you work together with somebody to understand what they're doing, something magical happens. I want us to make monitoring part of building software. Think of it like TDD for production. Right now, when we're doing test-driven unit testing development, test-driven development, we start with a failing test, theoretically, and then we wait until that test is passing by changing things and fixing them, and we make better and better tests. What would happen if we started with a failing health check for monitoring? And in order to do that, like right now, that's really hard. Sometimes it's multiple teams, right? And that's why I want to talk about coming together and working together to figure out how to do this. As people who are experts in monitoring, it's your responsibility to make it very easy for people who aren't experts in monitoring to do monitoring. Travis CI did something really cool, and I know that other companies have done this, including Yelp. I saw a really cool presentation on it. What if you had a YAML file you could drop in the root of your GitHub repository that just gave you monitoring? You have a grammar, and you can specify it in YAML because that's like our weird shared configuration language that's awful, but it's fine, YAML's fine. So what if you could drop this in, and yeah, you're just ready. Even before you deploy, you have monitoring. That would be really cool. You could start with a failing check. We have to understand how our systems behave. Like I said, I have distributed systems problem. I'll start there. I have distributed systems problems. And what I wanted to do was figure out, well, what are the failure modes here? I'm not expecting everybody to go out and do 30 years of research in distributed systems because there are probably people that you work with that are building distributed systems alongside with you that can talk about the ways that it fails. I met a lot of really cool people at a conference recently who are teaching me a ton about distributed systems, and I'm so ecstatic that I met them because I wouldn't be as interested in this had I not gone and took it upon myself to meet people who are really passionate about this. And there are people like that you work with, almost certainly. My favorite thing about Monitorama is to talk to people about what they are doing or what they want to do in monitoring. The sad part about this sometimes is when somebody comes to me and says, Greg, I have this idea. None of the tools at my disposal can do this thing that I want them to do. Like, a big thing that a lot of people talk about is like event correlation, right? It's a really hard problem to begin with, and our tools, it's not even a first-class citizen in basically any monitoring tool. I'll argue with anybody about that at any point in time during this conference, too. So to anybody that has said that or will say that to me this week, I want to apologize on behalf of everybody building monitoring tools for having failed you. Because I think, as people building monitoring tools, it's our responsibility to build features that people need and to build tools in a manner that allows us to meet those features as the way we build systems change, right? We do a lot of posturing in the monitoring space. We live by our marketing material that supports the fundamental assumption that we make about how we build our product. I'd really like us to stop living by our marketing material because we don't all build the same tool, and none of us, I guarantee you, no one selling anything here builds the one tool that's going to solve your problems. Because the thing is, we're building complementary tools. And coordinating the output of all those tools is really difficult, but we're part of a holistic approach to understanding the health of your systems, and that's important for us to all agree upon. Think about distributed systems. It's a really challenging space of problems to consider how the service that I'm responsible for taking care of, if I have one service, right? It's incredibly challenging to think of that in the greater context of the higher order system in which it's operating. And I know some of us have like the one public API that we only expose to customers, right? We are basically one service, and we think of ourselves in isolation even in that context. Your SaaS is part of a distributed system. You're selling it to people as part of their system, and we have to think about it that way. So like I said, I did a ton of research for this talk, and you are going to want to take a picture of this slide because these are really good papers. I know this is highly legible. You will have noticed the bracket points in my slides. You can read those first 4 entries. This is an eye test too. My optometrist is a serious masochist. But no, so obviously I have a GitHub repository with references. I got this from Katie, who got it from Ines Sombra, and it's like the best thing ever, so everybody should do this all the time. If you want to talk to me about monitoring, operations, infrastructure, distributed systems, if you want to share with me your passion, why you're here at Monitorama, feel free to find me at any point in this conference. I am the big, southern, flamboyantly homosexual one, so yeah, let's chat. Thanks so much for listening to me rant and talk and pedantically define things. Thank you, Monitorama, for having me, Jason, organizers, vendors. Everybody enjoy the rest of the conference.